So far, we have discussed about OLS, that is a simple linear arrangement, co-integration, etc. So I would define and summarize what we actually mean to do whenever we were talking about OLS or VAR. And in time series, most of us usually define the relationships for the long run or the short run. So whenever we are running OLS, that means it is a simple long-run relationship, and the problems with OLS for time series data is clear to all of us that the relationship would be simply a spurious relationship, and there might be a severe problem of autocorrelation and so on. And if these problems are there, we would not be able to trust the estimates or the estimating model from OLS regression. And based on these observations, Granger introduced the testing of causality, that is in 1969, and actually they used a different format of the simple OLS that included the past values of the dependent variables and independent variables. So if we remember, that was one of the form of VARL and so on. So therefore, we usually define Granger causality based on VAR, but we can also do it for one way of the equation. For example, we just estimate the relationship between y and x. That is a simple OLS regression equation, and then we include the difference and simply the length of the variables into the model. We would be able to identify the causality test. But most commonly and most well-known approach is VAR, that allows us to test these causalities for all the equations in all the variables at the same time. And then in future, we recommended to identify, for example, the short run and the long run relationships. And we introduced the concept of VECM and co-integration, that is from the Johansson and Zuzelius approach. And later on, we also identified that these problems are also, for example, not applicable in cases when there is differences in the conclusion of integration order. So that is, for example, if some variables are I1 and some are I0, so we cannot use the simple Johansson co-integration tests, and we can estimate the model based on the vector error correction model to define the short run and the long run relationship. So with these problems, Pesaran and the other authors introduced the approach of ARDL, and that overcome the problem of actually the mixed order of integration to conduct short run and long run tests to identify the relationships in the short run, in the long run, and simply the causality. So in terms of relationships and effects, the causality is actually a joint effect of the independent variables, of a group of the independent variables and the dependent variable. So ARDL might be used accordingly because we have the same and dependent variable on one side, and there is no other dependent variable like we have in VAR, which allows us to use that causality tests across the equations. So therefore, we usually have to use one-way causality, that is from the independent variable to the dependent variable, and we can use both the long run and short run form of the equations. And that also has one limitation, and that key limitation is actually the reason why we need to use that NARDL, that is nonlinear ARDL. And if we remember from our theories in economics, we might see that a positive change might not be affecting the positive change in another variable, like if one of the independent variable changes positively, that it increases, then we might see that a positive relationship, if that is a positive relationship with the dependent variable, then we might see that the dependent variable will also change positively, that is, it will also increase. And simply, if we assume that the independent variable changes downward, that is a negative change, then we might see that there should be a negative change in the dependent variable as well. And if we assume that these two types of the effects are equal, then we can simply use the ARDL or the VAR to identify the causality and simply the long run and the short run equations. And if we also see that no, the relationship are not like working exactly the same way, and if we just think about the relationship of consumption and income, we might see that a change in consumption might lead to more income, and simply a reduction in consumption might not lead to a reduction, a similar or equal reduction in the income as well. So these might of the possible applications in macroeconomics lead Greenwood, Nemo, and Shin to identify that there is asymmetry in the relationships. That is, if they split the relationships into a positive change and a negative change, they observe that these changes are not equal accordingly. So they decomposed these variations from the ARDL model, and then they identified the relationships in the form of NARDL, because these are not actually symmetric changes and the two changes are not equal to each other, and simply this is the main reason that we call it a nonlinear. And this is not a nonlinear model in the variables like we have an x square or y square in the equations. And the main reason to call it a non-linear actually is that the effects of the positive change and the positive change in the dependent variable, and a negative change in the independent variable, and the negative change in the dependent variable is not equal, because we will not see that these two changes are not equal actually. So this is the main reason that we have to identify these relationships in the form of NARDL. And one of this is basically the key reason, and we have to identify the answer of the question like why we need to use NARDL. And most of the times, whenever we have to justify in our theoretical contributions and simply empirical to provide empirical evidence while we are working on our thesis or research papers, we have to give the same logic and we have to prove this logic through our assertions and simply assumptions based on our theory, and we have to identify these kind of radiations. If we are able to identify these kind of asymmetries or not equality between the positive changes and the negative changes in the independent variable and the dependent variable, and if we still assume that ARDL is applied, then we might be questioning that as there is no symmetric changes in the dependent and independent variables, so ARDL will not be capturing it, simply VAR or VEC will not be capturing the relationships very truly. So in that case, we would have to use NARDL. So the key reason and the main reason and the only reason that you can say to use NARDL is exactly. Okay, so I would keep in mind that your email will be listed down in the future workshops. I would send that email. So I think Rahmat has asked something about the emails about the workshop. So I would keep your email in the loop. Okay, so if we remember the previous discussions on the same VAR and VACM and the ARDL as well, and we just find out a key reason of why we need to NARDL. We just need to identify for the same reasons from literature. And from literature, I would have to identify a key aspect of the relationships between the independent and a dependent variable, and whatever, for example, is the number of independent or dependent variable. But you have to keep in mind the same thing that if the positive effect of independent variable and the negative effect of the independent variable, if you assume or if you can presume that these would not be working exactly equally, like the effect of independent variable on the dependent variable is not symmetric or not equal both in the positive direction and the negative direction, then the case is exactly for the NARDL. So looking into that, we would be proceeding with the estimation, and we can do it very easily with Eviews and simply in Stata as well. And I would just show you, for example, from where we have to find out the codes for Eviews and simply for the Stata as well. So if you just look into that website of the greenboardeconomics.com and then publications, I would just look into the paper of modeling asymmetric co-integration in dynamic multipliers in a non-linear ARDL framework, and you just need to open that and then just click on the show hide details. You would see the same codes for different softwares, and we can use it in Gretel, we can use the GAS software, we can use Stata multiplier, that is simply an ARDL code, and simply we can identify the Eviews. But using these multipliers in Eviews from the codes of Nisbet is a difficult one, so we would proceed with a simple way that we can do it alternatively using that stepwise regression and decomposing these variables into the positive and negative using a simple course that I would discuss one by one here. So in Eviews, we would proceed first, and I would decompose any data that I can do it. And that is, for example, simply the food prices and inflation, food supply and inflation in different countries. We have the same codes, and I would just replicate that on my own data. and whatever I can do it. So for example, if I just close this one, I can just select any two variables on my from my data set, like I can use that trade and simply GDP, and simply any other two variables we can just do it. I would use, for this example, I would use only one independent variable and one dependent variable, and you can just replicate the same thing with two or more independent variables. But make sure that when you add further variables, the sample size should be sufficient to allow you to identify the relationship. Otherwise there will be a problem of the degrees of freedom, and the estimation would be giving us like limited observations or asymmetries and so on. There might be some other problems that we usually see with the smaller sample sizes. And I can just, for example, use two of the variables, that is GDP, and I can also see date and so on. I can use trade. So I would just replace these codes with one of the name of the variables that I would have to do it. So for example, this is my dependent variable that I would use D, and simply I would email this code as well. And the other variable that I would be using should be, I would be using that trade as well, or GDP as well, and I would just use the replace and the not trade. So I will just do it really quickly. That should be GDP. Let's say that I am using GDP for that, and I would see the code. Now I can see that all the variable names of the inflation is replaced with GDP, and I can just use this code. You have to keep in mind whenever you are using these codes in Eviews that the spelling of your variable should be exactly similar what you see on your list of the variables, and maybe the capital or small letters would not matter, but the spellings should be correct irrespective of the smaller capital letters. And now once I'm done with replacing these codes, I would just run these codes one by one, and I have to make sure that I have the command menu open. So let me just copy it from here. So I can see that I can just run this code, but you have to be very clear, like, for example, what is actually working behind the scene. So that is generate command, and that is general command. We can just create different variables. Like I can just create a variable that should be, for example, containing a variable 1 or 0 or anything. So you can just run, that is just simply running the simple codes. And if you just do it very clearly and specifically, Eviews would create the same files with that, and we will be just looking into the Eviews data section so we can identify whether the code is working or not working. So if I just look into that, I have generated that is one of the name of the variables that I have created, and the values should be equal to 0. And if I just open it, I would be able to see that the variables contains value 0. And is I would be doing it a little bit differently, because I have to create the differences of the date variable. That is the first differences of the variable, and that is the name of the actual variable. And if I have to use the lagged values of a variable, I just need to put -1 in parentheses after the name of the variables. So if I just keep my cursor at the end of the line and then press enter key on my keyboard, the same code would be working. I would get another new variable in my data set so that I can see, and that should be produced as well. So this is, for example, the first differences of the date variable. That would be my dependent variable, because if I have to run in simply ARDL, and I know that the ARDL contains the first difference of the dependent variable in the equation, so I would be using the same thing. In the first observation would be missing because there is no previous value, so the missing value will be generated for the first code. And simply I can just copy all the other codes, and I would explain it here very quickly. I can see that that is again the first difference of the GDP variable. And if I look into this code, that is a little bit different in working, but I can see that I generated the differences. This is the first difference of the GDP variable, and this shows that I have to create a new variable, that is POS, and let's say that is a positive variable that contains only the positive changes in the dependent variable or the independent variable, whatever the variable is I'm using. So I can just create a new variable positive that contains the positive changes. Only positive changes are the change it is equal to 0 within this specific variable that I already created. And if I just, for example, look into this code, it is creating, that is would be a dummy variable that I can, for example, create a positive change that I have renamed it. That is the first difference of the GDP with the P, and that shows that I have just identified a series with the positive changes in the dependent, that is the GDP variable. And if I just look into this code, I can see that it should be 1 minus positive, that is a negative number, and that would be giving us, for example, the negative values as well. So I can just summarize that, and the last code, the segment of the code shows that I have created cumulative sum, and that is actually the multipliers that I would be using for different others. So this is a cumulative sum of the squares of the positive number and simply the negative number of the variable that I would be using. And simply if I'm using another variable that is another independent variable, then I have to replace this code, for example, with a thread variable. So I would be using, for example, the same variable, but now I would replace it like thread here, and simply all everywhere where GDP is mentioned, I have to replace that with thread. So I can create the positive and negative cumulative sum of squares of the positive and negative of the thread variable as well. So I can just replace it one by one, and first I have to run these codes one by one in Eviews, and I would just copy it here. And the line, the code, the line that you want to run, for example, if I want to run the first line, I would have to keep the cursor at the end of that line, and then I would just press enter, and you can see that that would be going into the history at the end of the code sum. But that variable that is mentioned before the equal sign would be created in the data series that you can verify later on. And simply I can create another code or another variable, and simply one by one I would be running these codes on, and all the variables in my model should be produced, and I can use that simple procedure that I have to estimate an equation between the long run and the short run of the specification of the variables. And if I look into the codes, I have already created a simple format of the equation. So if I look into the short run and the long run specification, if from the VECM format of the discussion that we had earlier, I can see that that is a simple relationships, and that we can identify should be forming the long run relationships between the dependent variable, that is the difference of the variable. And we can also simply use that the d date of the date of the variable that I'm already done with that. So I would be using the date variable here, so that should be date for me, and simply I can just replace it with everywhere where I have mentioned another name for that. So now I can see that these are the two lines of the equations, and the first line contains variables with the legs and simply the levels of the variables of the labels of the variables that I have included in my equation. And the second part of the equation contains differences of the variables. If we remember, that is the short run part of the equations, and we have to identify the combination between different legs, because I have to use either the first leg or the second leg or combination of the first and the second leg. So I can use, for example, up to 3 legs everywhere in the equation. And if I just add another variable, for example, as I mentioned earlier, I can just specify other variables here in this part of the equations, like I would do it simply for this, and I would just replace the same equations for the trade as well if I have to include another variable in the equations. And simply I would have to do the same copy and paste for this part of the equation as well, but we will not be doing in this demo. So I would just replace it. But the working and extension of this code to two or more than two independent variable is simple, and we can do it. And you have to remember that this is the long run part of the equation, and this is the short run part of the equations. And actually that ARDL is an OLS model, but that contains the legs and the differences of the equations. And so this is a dynamic model, because I already mentioned that that should be a difference in dynamic OLS. And that was, for example, for the short run specification of the causalities test by Granger in 1969. But to estimate in ARDL between the positive and negative cumulative sum of squares for the given variables, I have to specify these two parts of the equations separately. In Eviews, I can do that by going into quick and then estimate equation, and from there I have to use that stepwise least square, and that is actually the two parts of the equation that I have to mention on my equation. That is the long run of the equation, the long run specification of the equation. So I have to copy that part of the line that is actually the same variable that I have to see on my long run equation in my specification of the relationships, and simply the other one is the short run, and that should go to the regressors list. And from the option I have to select a few options because I want to select only the relevant and significant contributors towards that model. And if we remember from the theory of ARDL, I can see that we have to run a lot of different equations, and from where if we remember from the theory of ARDL, we can see that we have to run a lot of different equations, and from within these equations, we have to select only the part of the model that contributes significantly to define that co-integration. And that is exactly done by stepwise, and we have to identify only the significant variables in the model. So I would be using the stepwise and unidirectional specification, and then backwards. And from here in the p values, I can use either zero point 0.5, or I can use 10%, or I can use 0.05, any level of the significance that you want to use. So I can, for example, use either 0.05 or 10% at least. So I would include only those variables whose significance is less than 0.05. That is, for example, the p-values of the regressors in the model should be less than 0.10, that is 10%. That is exactly according to the 90% of the confidence intervals. So once it is specified and you have identified that the relationship is unidirectional, and we have to use that backward, that means that only add that variable which is significant in the equation. So we would be specifying that relationship between the long run specification and the long run specifications. So once it is done, we can just click on OK, and we would get the relationship between the variables, and we can identify. So if there is a confusion, sometimes we see, if we just look into that specification, when we see that the option we have specified only 0.10, and if I just change that, for example, to 0.05, let's say if I just use zero point 0.05 and then click on OK, I can see that the first part of the equation does not contain any of the relationship that is significant. So that can give us a sense that the significance justification is from the list of the variables that I want to select, because I have already pre-selected these variables, and that procedure, when I'm talking about, for example, selecting those variables, the p-value of which is less than 0.05, that means that I'm selecting from this part of the equations, and it should not be applicable to this part of the long run equation. And it is predefined, and we have just to run the equation. Whatever is the p-value, we would be getting it, and only that part of the equation from where I have to select different legs. And that might be, for example, I can change the legs to be -4. So that means that up to the leg 4, I have to include the variables, and simply I can use another label that is 10%, or simply I can use that 0.05 as well. So any level that you want to use, for example, you can use 0.01, and that the justification is based on your assumptions in your observation from the literature. So I can just select, for example, that specification determines the relationship within these leg structure of the variables in your model. So once it is done, we can just identify the relationships, and now we can see that when I use 0.05, so most of the variables will be significant in the second part of the equation. And now comes that part of the discussion, that how can I identify that this ARDL, that is on the positive cumulative sum of squares and negative cumulative sum of square, is actually determined based on the co-integration. So there are some tests that we need to confirm, and before running any other assumptions tests. For example, if I want to test that whether this model contains any heteroscedasticity or autocorrelation or anything else from the same procedure that we already know, that if I want to test any assumptions of the model, then I have to test about the residual diagnostics or stability test, etc. So, but before that, we need to identify that the relationship that we have determined contains cointegration. That is, there is cointegration indeed between the variables, and that there is any causality or there is any asymmetry at the same time. So the 3 points that we need to remember is that the coefficients are not exactly what we see here in this result to interpret and then base our discussion for hypothesis testing. What we would have to do, the actual coefficients between the relationships of the given variables and the independent variables and the dependent variable should be that we have to divide that positive coefficient with the dependent variable in the length. So for example, if I just divide this coefficient with this one, and then for example I identify the sign and then change the sign of this coefficient after division, we would be getting the same coefficient of the long run in the variable, that is the GDP of the positive, and simply I can identify the negative cumulative sum of squares of the GDP that determines the dependent variable. Let me have a chat on that. So how much sample will be sufficient? Okay, so sufficient sample size is not a single answer that I can give. So for example, the simple answer is as large as possible. In most of the times, if we remember, for annual data set, we might be unable to find a sample size of 40 to 45 years. So that might be the extreme sample size, and the maximum sample that I can get should be 45 to 50 years of the data. But in monthly data, that is again, so if you have 40 years of data and then you just convert that into monthly, then that means that 12 into 40 number of observations. So that is up to you, and you have to determine, for example, how many years of the data you have. And yes, the sample size should not be small enough that you cannot estimate your model. So for example, if you have 25 years of the data and you can identify only 2 or 3 variables, and you are capable to estimate that model based on the given number of years of 25 years, then it should be sufficient to judge. But again, you have to remember that the critical values that you would be using for the different papers to test your hypothesis would not be based on that 25 number of years. That paper might have used 35 to 40 years of the data to determine their critical value. These are some of the key points that we should remember whenever we are going to use sample size. So to me, for example, the most commonly the sample size in time series econometrics for annual data is 35 to 40 years. And you can, for example, see that there might be evidence to use 25 years or 30 years as well. But again, I would see, for example, if I can use the critical values that are being determined for 35 years of the sample size, and I'm using it for 25 years. So I would not be able to justify why I can use that coefficient value, for example, for 25 years based on the critical value of 35 years of observations. So you have to be very specific with these kind of observations in your analysis. So I would be, for example, recommending to at least use the number of years to be 35 or more than 35 for time series econometrics whenever we are using annual data. And for sufficiently, for example, for monthly data or quarterly data, the same number of observations, for example, 35 to 40 number of observations. That is not just, for example, for years. If your quarterly data is 35 quarters or more than 35 quarters, it is again sufficient to answer and justify your observations. So I was talking about that coefficients, for example, what will be the actual coefficient of our long run equation. So I would be just converting this coefficient divided by the coefficient of the dependent variable in my list of the regressors, and you can just see that the det is actually the dependent variable, and I have included det with the first leg. That is actually the specification of ARDL equation. If we just look into our previous lessons, we can see that the ARDL contains regressor, the dependent variable as well in the regressors. So I have to divide all the coefficients of my independent variable in the first part of the equation, that is the long run part of the equations. So one by one I would have to divide. For example, the first I have to divide the positive sum cumulative sum of squares with the det, and simply just divide this coefficient with this and just change the sign. That would be the actual coefficient of my observation. So for example, if I just change my coefficients into the same observations, so I would just, for example, I would be using the same coefficient, that is the generator positive underscore GDP coefficient, and I have to see that that should be the value that I would be using from here. And then simply the coefficient of the dependent variable, And I'm just using this to demonstrate. Otherwise, we can do it with handheld calculators or on our computers calculator. So that should be even the simple way that we can do it. But I'm using Eviews to do it, and it is very simple for us. So a minus sign, and then I have just closed this in parentheses because it also contains its own minus sign, and then I can just close these with the parentheses so that the minuses are not confused, and we can just create the results. So I would just, for example, get where the coefficient, and it should be created a new variable that is positive underscore GDP, but that should be a single value across the column. So I can just create it. So for example, that shows that minus 2.18. So that means that the coefficient of my dependent variable, the independent variable of GDP, the positive cumulative sum of square of the GDP is actually minus 2.18, and I can just see that it is positive, significant or not significant, and simply I can do the same thing with the negative, and simply in the short term variables are just determined according to the equations, whatever the coefficients are here. We just need to use these coefficients, and the significance should be determined based on that. So once it is done, we are done with, for example, calculating the actual coefficients to be used for interpretation in the long run specification of the equation, and then the short run coefficients to be interpreted based on these p values and then these simple coefficients. And the other one is that to determine whether there is any cointegration or no cointegration, I would be using these coefficients for a simple walled test, that is exactly the F test, and that is exactly again the bounds test that we actually know about the ARDL test. So if we remember the ARDL bounds test, and we are actually using it as an F test on these coefficients of the variables. And you have to remember that the first coefficient in Eviews is C1, second coefficient is named as C2, third coefficient is C3, and so on. If you do not remember this specification, you can just click on view and then click on representations, and you would see that the coefficients are determined based on the first coefficient and simply the second coefficient, and then third coefficient and fourth coefficient, because these are the coefficients of the first part of the regression, that is the long run part of the regression. So I would be using these three coefficients for my F test, that is actually the bounds tester, to determine whether there is cointegration or no cointegration. I do not think that there, oh yes, luckily, though I do not remember that I started recording, but it is recorded. So there is no problem. Thank you very much for reminding me, but I was not sure that whether it was recorded or not recorded. So let's see that what we do it later on with that. Thank you very much for reminding me at very late time. Okay, so what I was talking about, the signs of the coefficients, and then using the F test to determine whether there is cointegration or no cointegration. And I can just, for example, if I just look into this regression, if I do not know the name of the coefficient of these variables to be used for walled test or the F test for bounds testing procedure to determine cointegration, I would just click on view and then representations, and then just remember the name of these coefficients, that is C2 and then C3, and I would just click on view and then coefficient diagnostics, and determine that you have to use this walled test of coefficient restrictions. So I can just use the same three coefficients. That should be very simple for us to do, and then equal to 0. So if I just create this simple statistic, and you need to remember that the critical values have to be taken from the Pesaran paper, and you have to identify the relevant table, because there are many tables that you need to remember. So I would give you a very quick view, for example, how to determine the tables for that. So I would just use it, and I can just use this F test. I can see that the value is 39, and then I have to look back into my equations. And if I just remember in my equation, I can see that I have just determined the relationship between debt and GDP. That means that I have one independent variable. So from that piece around paper, from the bounds testing procedure, where I have to use the critical values, and that is the paper of 2001 from Pesaran and his authors, co-authors. So I would be using one k, that is k is equal to 1. Why? Because I have used only one independent variable, and that is actually between 1 and 2. and because I have split this independent variable into two parts, so this is actually one independent variable with two components actually, and simply I have not included any trend in my equation, so I would be using only the intercept form of the equation with k is equal to 1 and no trend. So from that table, I would be looking into the corresponding alpha level, either 1% or 2% or 5%, and then I have to check with the maximum and the minimum critical values, and I have to see the same results for my wall tester here, that I see that it was 39. So if this is, for example, greater than the upper limit of the F test from the critical values table of the Pesaran et al. In 2001 paper, it would confirm that there is co-integration. So that is, for example, the most of the times that critical values is around 7 to 8 or 10 maximum, and my value is 39. So I can see that there should be co-integration between these two variables. So I'm lucky with that, and I can see there, for example, a confirmation about that there is co-integration. And the third step, whether I'm doing correctly or not correctly, but I have to remember that I'm running an ARDL, that is not a simple ARDL, to confirm that there is co-integration or no co-integration. So the first problem is actually interpretation. In most of the problems, whenever we are using NARDL, the confusion arises how to interpret the coefficient. We can see that we have to divide the coefficients of the positive and negative cumulative sums with the dependent variable with the lag values, and then change the signs. And then the second step is the co-integration test that we conducted from the view coefficient diagnostics and wall test, and then I just mentioned the coefficients of these three variables in my list. And the second so the third and the last step before we validate this model for assumptions, and we will not replicate the same thing because we know that we can just click on these assumptions and we can just click the results. So the key point whenever we are using NARDL would be to determine that there is a symmetry actually. That means that the two coefficients that we actually use for positive and negative effects of the positive changes and the negative changes, that is actually the cumulative sum of squares for the positive changes in the independent variable and the negative changes in the independent variables. And our assertion in our assumptions to use this NARDL is that these two variables, that is the positive and negative changes in the independent variable, has a no equal effect on the dependent variable. If that is my assumption, I can base a simple if test on this assumption as well, whether these two variable has the same effect on the dependent variable or no same effect. That means that it is the test of a symmetry that I have to confirm, and I can do that very easily again with respect, because if we remember that I use the coefficients to be that the actual coefficient is this coefficient divided by the coefficient of the dependent variable, and similarly simply the coefficient of n is actually this coefficient divided by this one. So I would have to use the same test term, that is the wall test, and I would confirm the same signs of the coefficient, that is a C2, that should be C3 divided by C2, and my assumption is that these should be actually not same. So for example, if this is my assumption, this is my null hypothesis, and my assumption is that actually the effect of C3 and C4, that is the positive and negative cumulative sum of squares of the GDP, has no equal effect on the dependent variable. So the actual coefficients was determined exactly using this formula, and I can just determine the actual coefficient of the second part of the, that is the negative cumulative sum of squares, and I just use this and we can determine the if test. If for example if this is my null hypothesis, that means that I assume that the two, that is the positive and negative cumulative sum of squares, has same effect on. Alternatively, that is the alternative hypothesis should be that there is no equal changes, that is the no equal effects of the two coefficients on the dependent variable. So if for example I would be using the if test and using the p values, I would be able to reject this is there is a symmetry or no symmetry. I can just use it. If I just look into the if test, I can see from this result that if I just look into this p value, I can identify that there is no asymmetry. Why there is no asymmetry? That means that the two coefficients are actually equal in the sense. So if I just look into the last tables And my equations, that is the null hypothesis, was exactly the same, that the two coefficients are not equal. And if I just look into this restrictions and this p-value, I'm unable to reject the equality sign. That means that I have to accept the alternative hypothesis or the null hypothesis based on this p-value. If the p-value is greater than 0.05, and a convention is that we have to accept the null hypothesis, and the null hypothesis there that the two coefficients are actually equal. That means that in this complete analysis, there was no asymmetry, though there was co-integration, and I can identify the relevant assumptions and the precautions, and simply I can identify another model because I have not included any other variable in the model. So I would be able to identify another variable from the literature to add into this model, and so on. So until I get a relevant model, a true model, I would be able to practice the same thing again and again, and I would finish up with a nonlinear ARDL model for my thesis or my research article. And this is how we do it in Eviews. And in Stata, that is very simple and very quick. We just need to find out whether we have that NARDL installed on my computer or not installed on my computer. So what I would do is, most of us know that I have to use that find it code to identify whether there is any RDL published in the Stata libraries or not, the related links. And if there is no link, I can just find out from the external sources that we already know, that I have to identify the link from where I can download that NARDL code. So if I just look into this, I can identify that Greenwood Economics, that is actually the Greenwood Nemo website. So he is, for example, using greenwoodeconomics.com, and we can just identify and download these NARDL codes and just copy it to the folder from where I have to take it to the Stata folders again. So I can see that I have downloaded these folders from the website, and then these are here, and I have already downloaded these codes. So I would be copying these two codes, that is nardl.ado and nardl.hlp. So these are actually the two codes that I would be copying to my Stata library. So I would just go to C drive, and then the ADO, if Stata is installed, this ADO folder will be there, and then click on the plus, and then you, because the course begins with N, so Stata would look into that N folder. For example, if I'm just using the code that is NARDL, dependent variable, independent variable, and then options, because I have to use the code for that, and the code begins with N. So Stata would automatically look into the folder with the name N. So I have to copy these two codes from the Stata folder on my D drive or the F drive to this, and I would be able to use it. So you can see that I already have installed this, and I can just, for example, identify this in my Stata as well. So once it is copied to the Stata LDO libraries, I would be able to read the help file for NARDL, and it would explain, for example, how to use it. So it is a simple code that we actually use, that I can use the code with the given name of the variables, and simply this is the name of the variable that Greenwood, Nemo, and Shin, etc. are using in their own paper. And these are actually the number of legs that, for example, the legs of the dependent variable, legs of the independent variables, or you can see that legs of the level variables and legs of the differences variable. And simply that is the deterministic variable, whether we want to use monthly or quarterly data, and then we just use monthly or quarterly dummies into it, in any other deterministic variable in the model, and how many time periods we want to use for the horizon, and whether we want to the residuals to be recorded in the variables or not recorded. So I would just copy this code to my Stata, and then I would just replace the two variables that I used. For example, that should be datum and then JDP. So once it is done, for example, I would be using, let's say I would be using 2 and 3 is the legs, and then I would be using, that should be trade, for example, another variable that I'm using, and I would be using 35 is the horizon, because I have 35 or 36 number of years of the data set, and then I would be using the residuals for that. And once it is done, for example, the codes will be produced and the results will be produced for me, and everything that we did manually and Eviews to identify whether there is a causality, there is a symmetry or no asymmetry, we can just use the same code in Stata, and it would be giving us the same results in different parts of the results. So I can identify the p-values and so on. I can reject whether there is causality or no causality, there is a symmetry or no symmetry, and we can just, for example, use that quantification test statistic. If we just look into the F test and so on in model diagnostics, everything is produced within the same one line of the code in Stata. So this is why one of the reason that I use NARDL whenever I'm doing that analysis for someone, for example, using this NARDL, because it is just a one-line code. You just need to input your variables, and everything that you need to determine is given in the same one line of the code. And in Eviews, though we can do it, but the code, the steps are different, the analysis is different, and we can just identify that the steps are actually somehow, if you are not aware of these steps, for example, how to do different things, then the job becomes very complex. Now, I'm sure that this simple introduction to NARDL, the key point of this workshop is to identify the main reason, that is the earlier, the main key point, that why we need to use NARDL and then how to use NARDL. I'm sure that this simple workshop would help us remember this practice, and we would be able to contribute something towards literature. And why I conducted this workshop is actually the same thing, that papers that appear in most of the recent literature is actually based on the asymmetric causality and that NARDL. So I'm sure that if some of us can write one up to a papers, we can very quickly publish it if we are doing that NARDL for the analysis. And thank you very much. If you have any question, we can just discuss it.
Hello. Hello.
Okay, so I think there is no question. And if
Hello.
you have any other question, you can just watch the video and then send me a specific question on the part of the video or anything that you are doing on your own data, and we would be replicating the same thing, and I would answer your question using your own data. And I would be sending that video recording and also the certificates in a few moments when the recording is processed and certificates are validated. Thank you very much for the time being. Okay, so for the time being, I would say goodbye and see you with another question if you have. And we will be having another workshop somewhere in the mid of the September, and we would have a particular class on next topic. So be prepared for the intensive penalty analysis for GE, heterogeneity and the GMM level. So I would see you in the class next weekend. Thank you very much.
Okay, sir. Thank you.